in 2010. He has received a Best University Teacher Award from the Government of Goa in 2017. Presently, he is holding the position of President of Mycological Society of India from 2020-21. When we refer to the greatness of a person, the greatness of person is measured because of the reputations, recognitions and awards received by him. His research paper published in Aquatic Botany Journal was adjudged as top 20 hottest articles in the year 2007. One of his research papers published in Journal of Forestry Research was ranked in the top 20 cited papers in 2013 and 14. And for this paper, he was awarded a cash prize of $1,000 US. Apart from his educational and research experience, he has visited more than 9 countries for academic and research purposes. So I welcome sir on behalf of Colonel Bhara Patil, Mahavidyalaya, Pandharpur. Thank you.
Thank you sir for such a nice introduction. Now I request Professor Dr. B.F. Rodriguez sir to deliver his talk on mycorrhizae in sustainable development.
But to engage the stronger nervous system. The air is connected to
Hello?
yeah, here everything is fine, Dr. Kilaro. Can you check from your side?
Yes, I'm just checking.
Hello? Hello?
Yes sir, you are audible now.
Oh, hello, yeah, okay, thank you. Well, good afternoon everybody. Principal Dr. J.C. Kilaro, my good friend, convener Dr. NMPC, organizing secretary Dr. A.B. Mamlaya, other research persons, heads of various departments, faculty members, and student and delegates and student friends. But I also am very happy to be able to this afternoon Although I cannot make it physically, but through this online mode for this 2-day-long international conference on microbes for sustainable agriculture, animal husbandry and environment, organized by the departments of botany and zoology of the college. Well, let me thank Principal Kilare and management of this college for extending an invitation to me to participate in this 2-day-long international conference. Well, I will be talking on the topic microbiology in sustainable agriculture. Coming to the introduction, we know that agriculture is essential for human survival and for long-term sustainability. Should be ecologically friendly, so that it will nourish the ecosystems, and also the ecosystems would, in a way, the agriculture would flourish. So sustainable agriculture is the buzzword today, which talks about safeguarding the ecosystems, about the environment, and the most important, the human health. Now coming to the soil. The soil is inhabited by a variety of microorganisms, agriculturally beneficial microorganisms. And some of these organisms, they have different roles, like they fix the atmospheric nitrogen, they solubilize phosphorus, and so on and so forth. And therefore, these microbes play a very, very important role in agriculture. And therefore, we need to use these microbes in the form of biofertilizers, so that we can use them for sustainable agriculture. And therefore, using them as biofertilizers, we need to carry out in-depth study of the microbial characteristics, the effectiveness, consistency, precautions and limitations, not only at the laboratory level, but also at the at the field level, so that they are working in the field. We see the different type of microbial bioinoculant that we have, like rhizobium, that is involved in the nitrogen fixation, azotobacter. Then again nitrogen is a living nitrogen fixer. Then phosphate solubilizing bacteria, which are involved in solubilization of phosphorus, blue green algae, then rhizospirillum, and then the AM fungi. So in today's presentation, I will be talking on the AM fungi, which are so very important in the context of sustainable agriculture. Now coming to the mycorrhizal system, it consists of the plants, the soil, and the mycorrhizal fungi. And you can see that these plants, they have this mycorrhizal association. It's a symbiotic association between the living plant root and the fungi, and therefore they are associated, like in the forest ecosystem. There's mycorrhizal involved. Different species are involved in colonizing the plants and helping the plants to get more nutrients and better plant growth, and therefore better yield. So if you see the whole earth as a globe, you find, like in the terrestrial ecosystem, there is a huge web of these mycorrhizal fungi in the soil, which are beneficial. They play a beneficial role in the ecosystem. So it's a symbiotic association. As I said, there is a bidirectional flux where both the partners are benefited. Here the plant is benefited because these fungi, they absorb nutrients and make it available to the plant. Like especially in the tropical soils, we find that there is nutrient deficiency. Like phosphorus is limited, therefore the plant growth is limited. So when this mycorrhizal they add to the soil, to add to the phosphorus for the plant, then it would increase the growth. So, and in return, these mycorrhizal fungi, like I shown you the Basidiomycetes, being a heterotrophic, it cannot produce its own, cannot carry out photosynthesis, so therefore it depends on the plant for its carbon compounds. So in such symbiotic association, we find that the plant gives about 20% of the photosynthesis to the partner, there is a fungal partner. And that's how there is a mutual benefit for both the organisms. You can see here that how the plants only with the roots. So this is one mechanism where the plant can absorb nutrients. The roots would absorb nutrients from the soil. But then when the roots are associated with the fungi like the mycorrhizae, then it helps to absorb better, more nutrients where the roots cannot reach, and therefore it would show better growth. So also phosphorus is an element which moves very sluggish in the soil. Movement is very slow. It's very and therefore you find that it creates a depletion zone. And for the phosphorus to move, it takes a lot of time, and that limits the plant growth. Therefore, when the plant is associated with mycorrhizae, then these mycorrhizal fungi, they go beyond the phosphorus depletion zone and they can absorb the phosphorus and other nutrients, and therefore help the plant growth. So also you see the size of the fungal hyphae and the size of the roots, there is a vast difference. The fungal hyphae are very minute, therefore they can enter into the finest crevices in the soil which the roots cannot reach. Therefore, such an association helps in better plant nutrient uptake and plant growth. There are different various benefits of AM fungi. I will not go into the details of this for paucity of time, but most important is that it increases the yield. It also helps to reduce the fertilizer inputs. When you add these mycorrhizae in the soil as a biofertilizer, it improves the plant growth and so on and so forth. Now coming to the fungal structures, the mycorrhizal fungi, when they associated and when they are colonizing the roots, they form unique structures which are not found in other fungi. Of course, this is the hyphae, intraradical hyphae. When we stain with trapen blue, you can see the staining, and these hyphae are non-septate. Except under certain conditions like in vitro or in under stress condition, they have become septate. Otherwise, most of the time they are non-septate. Apart from these hyphae, which may be found which are found also in other type of fungi, the AM fungi they produce arbuscles. These are small tree-like structures. They are called as the arbuscles, posterior-like structures, and these structures help in the transfer of nutrients from the plant to the fungus and fungus to the plant. They help in the nutrient transfer. So they are very important structures, and these structures are formed, say, for about 8 days. They remain 8 to 10 days, and they degrade. Now, whenever the plant requires phosphorus, then these arbuscles are formed, and they would provide phosphorus, and then the arbuscles disintegrate. So that is the role of the arbuscles that are seen in the mycorrhizal plants and the roots of mycorrhizal plants. And these are the vesicles. Vesicles have two roles. One is they help as chlamydospore. They act as reproductive structures. And secondly, these chlamydospores, they store the lipids. So they act as storage organs as well as they act as reproductive structures. Then the spores. The spores are produced by mycorrhizal fungi. They may be in the hyphae or they may be in the soil. So accordingly, they are termed as intraradical spores and extraradical spores. Then the auxiliary cells. These are structures that are found in mycorrhizal species. In those species which do not produce the vesicles, the function of the auxiliary cells, they are known to store lipids, but their reproductive structures, their function is not yet defined till date. You can see here that this is in vitro, where there is auxiliary cells produced. In vitro, as I said, it produces septate hyphae, and then we can see the auxiliary cells. And here the auxiliary cells, they are stained with Sudan black, then it produces this type of, that is the lipid bodies are stained, they are darkly. from the from different ecosystems from this on this planet. Now, how we work with the mycorrhizal fungi is that the soil, the mycorrhizal research is mainly based on the spores. These spores are found in the rhizosphere soil. So, by using a technique called as wet sitting and decanding of Godiman and Nicholson, we can isolate the spores. And then these spores that are isolated, they are later on trapped. So that the viable spores from the isolated spores, whichever are viable, they would multiply. Therefore, you get lot many spores in the trap cultures. So later on, these spores are separated, and then one can maintain pure cultures. So we have about 35 or 38 plus pure cultures in our collection. And then, of course, this is in vitro studies can be done. So trapping is taking a sterilized soil. Sterilized soil in a pot and then adding either the rhizosphere soil or the spores, isolated spores, and then adding a host plant so that the plant would grow and then we colonize with the viable spores, and these spores would multiply in the soil. So these are a few of the pure cultures that I have shown here. Now coming to the pale fungal diversity, as I said, it is spore based. You can see the different species which I have listed here in the next 4 or 5 slides. They show variation in color, shape, size, ornamentation, attached hyphae, and so on, and even the contents of the spore. So different species, these are Echinospora, and it is important that we have to produce the trap cultures. We have to do the trapping so that multiply the spores and then only venture into the identification of these spores. Otherwise, it's quite difficult because the spore, the young spore, you can see here, and this is the older spore, they show differences in their characteristics. Therefore, one has to be very careful while identifying, and identification has to be done at least by wearing the trap cultures. Again, these are some of the sporocarpic forms and some of the species. They are different, more than one attachment. Here there are 4 attachments and so on. Again, some more species of Perniciformis and Rhizophagus. Then this is Gygospora, different species of Gygospora, and they show peculiar characteristics. Like this shows a suspensor, bulbous suspensor with attachments, with appendages here. This has no appendages, and on the base they can be easily identified. These are with the presence of these germination shield, Recocitra, Scutellespora. There are germination shields. I'll talk about the germination shield a little later. These are again sporocarpic form. They form the spores are arranged in a sporocarp around the central plexus, and if you get 2 or 3 sporocarps, then one can easily produce the pure cultures. Here you can see, and the ornamentation it varies. This is Echinospora solvaria that we have identified from all lab. It has been identified from one of the species, and it appears like a radiating sun. The scanning electron micrographs of some of the PM species are very interesting, and they show different types. This is Echinospora kalinovi, that again from all labs that has been isolated from the sand dunes. Again a very peculiar mycorrhizal species. Echinospora kalinovi is the second one that we have added to the original. There was only one species under Echinospora, that was Echinospora baltica, and this is the second one that we have identified from the dunes from Goa. These are some of the features that how it differs from Echinospora baltica. Echinospora baltica has been identified from the sand dunes from Poland. Again, the ornamentation in baltica and in Perinovi is distinctly different. Even the colonization, you can see the orbicals. They are hard to identify, but by special staining technique we could identify this particular colonization in Echinospora. Then the molecular sequencing has distinctly, we have identified this as a separate species and it is very close to Cephalospora baltica. Now coming to the germination, there are two types of germination. When the spore develops, the germ will develop on the spore wall for many parts of the wall and then it will form into the mycelium and it will colonize. That is the one type of single germ tube. And the second method is we have the germination shield. I was talking about germination shield. This germination shield has got many germ tube initials, and each of these germ tube initials, the germ tube can come out, and therefore, in these species which have these germination shield, they can produce large number of germ tubes. Anyway, in vitro studies will be able to show you how many germ tubes coming out of the germination shield. This is a spore syndrome where the spores are deposited in old spores of mycorrhizal fungi so that they are protected from the predators. There are a lot of soil predators in the soil, and these predators can thrive on these mycorrhizal spores. They can bruise the spores, damage the spores, therefore it can affect the viability. So to protect the species, they lay them in the cases of old spores, and therefore these spores are safe. It's a strategy for survival. When coming to the trap cultures, I was talking about trap cultures of using a host plant, and then you can use any of these methods. You can use either the rhizosphere soil or the isolated EM spores or the seeding that is collected or the entire plant, or even you can use the roots. So here we have to use sterilized soil with the host plant and maybe isolated spores or any of these, and then the whole idea of trap culture is to multiply the spores which are viable in the rhizosphere. So this is another method. This is called the funnel technique, where we can multiply and get single spores. So if you can take a single spore or light spores and place it at the mouth of this funnel, then put sterilized soil in this, make a slit, plant finger millet, and then this whole assembly is placed in the conical flask with the absorbent cotton, and water absorbed, the plant would get water, the seed would germinate, and then when it reaches the mouth of the funnel, it will get it will have a mycorrhizal, it will get colonized because the spore also would germinate, and once we check the pollination in this, later on we transfer it into these pots, and then that's how we raise the pure cultures. So these are some of a few of the pure culture spores that we have been able to isolate, just to show that the spores they are identical. So different species would show different characteristics, and that's how the monocultures, the pure cultures are maintained in the polyhouse. So the plant we have selected is Coleus. We have also selected Stinger minute, that is Elucin parecana, because of the various features, like it shows fast growth, it adapts to the conditions very well, it can get readily colonized by mycorrhizal fungi, young fungi, and the roots are transparent, therefore you can clearly produce very nice slides and observe the colonization. And the production of roots is also large quantities produced, and the plant is resistant to pests and diseases. So these are the plus points which identifies Coleus as an important plant, important host plant. The different techniques that are used for EM inoculum production includes the in vitro culture techniques, then you have the pot culture, aeroponics, hydroponics, so that the inoculum can be produced on large scale, and it could be used for different plants or different crop plants. Like we tried something in we tried using mycorrhizae in different plant species, like Carica papaya. We identified funnily for which mossy as a very efficient plant because it helps in mineral nutrition. Then apart from that, other characteristics of the plant were enhanced, the vegetative growth as well as the reproductive growth. Then the phosphatase activity, there was an increase. This was observed again in our study that we published. And then in case of the ornamentals, this is in chrysanthemum, we could get good colonization, enhanced colonization in the mycorrhizal plants, and also the days that were required for flowering were reduced. So that was another. And then the number of flowers per plant increased. There was a significant increase in the number of flowers. So also in Prasandra, we could get that the mycorrhizal plants treated with mycorrhizal treatments, they showed better growth compared to the control plants. And now this is done because in mycorrhizal research there is something called as host preference, and there is no host specificity. Any fungus can colonize any plant, but we have to identify which plant would a particular plant as to which fungal it would prefer. So there is preference, because of which mycorrhizal research has to be done. This is in case of Endocarpus paniculata, where we also found that apart from growth, there was increase in the concentration of the secondary metabolite, which is medicinally important, that is endocarpaloid. And where we used Gygaspora albida as the mycorrhizal inoculum. In case of chilies also, we could get growth, significant growth as compared to control, and we could identify the species that is Claridium indicatum. So also Equilospora strobiculata was found to be a better mycorrhizal species colonizing the ladyfingers. Also in case of Cereopstracal, which is a mangrove plant, it's a very slow growing plant. We could use it and increase the growth in the mycorrhizal plants as compared to the control, and also the colonization levels increased. Not only the colonization, but it also increased the root growth. In mangrove plant, the root growth is very, very poor. So when we used mycorrhizal species, then there was an enhanced increase in not only in the shoot growth but also in the root growth. Now coming to the soil as an inoculum. There are certain issues, like every time we have to check the cultures, see that there is no contamination, there are no endophytes, no other contaminants getting in, and we have to maintain them in the polyhouse. And therefore, we need to check. Second thing is that when you use the soil as inoculum, that you have to ensure that the inoculum it works at any given point of time. In mycorrhizal fungi, there is some spores, they have dormancy. So if you add inoculum and if the spore is dormant, then nothing is going to work. So therefore, these are the things that we really need to look while using the mycorrhizal inoculum. We also used mycorrhizae on the mine dumps. We have the iron ore mine dumps. So dumps, and on such dumps we could carry out revegetation successfully. And we also used tissue culture plants. We cultured Trema orientalis, which is a plant that we have standardized the method for tissue culture, and we could get plasmabulbs plantlets which were colonized initially with mycorrhizae, and they have shown better growth in the field. This is how the mycorrhizae is added in the nurseries. A large number of plantations are done at the nursery level so that we can plant this in the field and monitor the growth. So with mycorrhizae and without mycorrhizae, you can see that the difference is very less. Indeed, showing that by mycorrhizae you can make a good saving, but apart from that, it is environment friendly and it sustains the soil microbes. That is the important part of this. Recently, we have been able to make a headway in coconut. So I was given a consultancy by one of the firms from Bangalore, where I was supposed to prepare identify the mycorrhizal species for coconut and also give an efficient inoculum for mycorrhiza. We have given a consortium of 3 species, which is very effectively working in the field, and you can see that even the grown-up plants which were not showing much mycorrhizal colonization after all inoculation, they have shown colonization. And not only the seeds, the nuts or the seedlings, but also the grown-up plants have been, using mycorrhizal biofertilizers, we have been able to get the results. you can see that the trees which were biofertilized by using mycorrhiza, they have shown the colonization of the species which we had added, indicating that it helps the mycorrhizal biofertilizers helps in colonization. Therefore, it would help in improved growth and yield. This is the other two parts, the growth and yield, we are monitoring. It will take us quite some time, another year or so, to monitor these parameters. This is the polyhouse where we have the mycorrhizal species maintained. There is the single spore cultures or the monospecific cultures, and you can see the colonization in these plants. There is extensive colonization. See the spores also, they are very fresh and viable spores. And this is important in case of in the in vitro studies. So limitations of field-based inoculum, soil inoculum I have discussed, and further we move on to the monogenic culture. So we thought that we would get into in vitro cultivation, and where there are no contaminants, you can produce large amount of inoculum, high quality inoculum in a small space, and you can carry out optimization of spore production by standardizing the techniques, and once the technique is standardized, then it is very easy to maintain. So this is in short, the root organ culture, how the germinated spore is placed amidst the roots, and there is colonization and sporulation. You can get large number of spores. So these are the tDNA transformed roots that are used in culture, so that within a month's time these petrichulates are full of these roots. Then we have carried out germination of these spores in vitro. The single spore cultures or the pot cultures maintained in the polyhouse, it would give us spores of this quality, and we would germinate the spores. And you can see the germination shield, a very clear germination shield, and from there the germ tubes. You see there are some 3 or 4 germ tubes. Then this is Recositra gregaria, different species where the germination has been carried out, and then this is in Gyrospora decipiens. Then these once you add the germinated spores amidst the in vitro, the roots, transformed roots, then there is colonization, and later on there is sporulation. You can see this. These are the auxiliary cells which I had shown earlier. And the sporulation, young spores, they develop in vitro. You can see as many as 25,000 spores can be produced in a single petriculate with viable spores. Now once this is done, you can see some more species, how the spores have been, new spores and spores that have been formed. This is in the Panelicornis mosaic, this is in Necrospora scrobiculata. Now using the vesicles and propagules we tried, and then we found in Rhizophacus sclerus, we could use these vesicles and we tried germinating them in vitro, and they germinated, and then after colonizing we could get the spores of this, spores which were transparent and which were viable spores. So once we prepare this inoculum, this sporulation in vitro, or we have the inoculum in vitro produced, then we have to use a carrier. So we tried different substrates, a combination of different substrates, and found that a very interesting study that showed that the combination using the substrate in different proportions would show variation in colonization in the plant. So this is one substrate that gave us almost 98% colonization as compared to the other substrate that gave 56%. And so that's how we could identify the substrate to substrate to produce the carrier. Then the carrier was used. It was by using Illusion corrigana or finger millet, we have multiplied it, and this was developed. The carrier was developed, and then we could raise these plants. And later, we tried again on coleus, adding coleus plants and checking the colonization in coleus with the in vitro produced spore, which is that carrier-based inoculum. And we could get extensive colonization even in the carrier-based inoculum that we produced. indicating that the spores that are produced in vitro, they are viable. So viability was very, very important. Otherwise, if it is not viable, then we are not able to use it as an efficient inoculum. We tried the in vitro produced inoculum in Keju, and we could see distinct difference in growth, very significant differences in growth. And since Keju is extensively used in the mines as well as on the dunes, so therefore we work with Keju also. Then, now this growth, whether it is because of Keju, because of mycorrhiza or because of some other reason. So therefore, we had to check the root system, and we checked for root colonization. You can see again extensive root colonization in the mycorrhiza plants. Further, we extended this to in cowpea. Cowpea is an important crop which is grown on fallow lands after the rice cultivation. So therefore, we tried it in different cultivars. We could identify about some 18 varieties of cowpea, and then based on that, we carried out studies by using mycorrhizal fungi. That is, as well as we also used some rhizobium, bradyrhizobium and PSP, and found that that this is a field experiment that was done on cowpea, where we used this is the inoculum of rhizobium, and these are the cowpea seeds. They were coated with the rhizobium, and then the seeds were planted along with the mycorrhizal inoculum. And here you can see that again extensive colonization in the cowpea with the inoculum that we have developed for cowpea. So very high rate, high amount of percent of colonization, indicating that our inoculum, added inoculum, is working for cowpea. And you can see the growth, the yield in different parameters. There is the number of pods and all that. So there was significant increase in the seed weight, in the number of seeds that were produced per pod and so on. Well, so therefore, what I would suggest is that, to conclude, that we have developed a technique for plantation crops like coconut, where it is really working in the field. There were a lot of apprehension that whether the mycorrhizal inoculum is going to work or is not going to work, how to produce it. But then that whether the pot culture techniques would work, but we found that it is working. And shortly we will be filing a process patent for at least for coconut, what we have developed. Since it is working, and then even the people who are involved with us, they are very happy with the results. So therefore, it is important that we need to slowly move, from inorganic to sustainable agriculture, the organic agriculture, so that is going to help not only the farmers in the long run, but also it is going to sustain the soil. It is going to increase, not only retain, but increase the soil fertility in the coming days. So that adding inorganic fertilizers will give you yield, but that is temporary, because there are large tracts of land in India which have been turned into wastelands because of the use of inorganic fertilizers. Therefore, it is high time that we have to move to organic agriculture, so that it is a sustainable agriculture. So with this, this is the last time. With this, I would like to thank the organizers for giving me this privilege to make this presentation as a keynote address, and also thank you all participants for your patience. Thank you.
Thank you, sir, for very informative lecture. Now I request Dr. S.V. Tide sir to propose the vote of thanks of this session.
Sir, Roderick sir.
Yes.
There is one more question from participant.
Yeah, I have 1 minute. I just.
Good afternoon, sir.
Yeah, please go ahead with your question.
Every span of time, farmer, it is necessary to provide mycorrhiza to plant. My question is that is it possible to sustain mycorrhiza forever,
To sustain mycorrhiza by?
for long time?
Yeah. See, definitely. See, the thing is, when we add this inoculum in the soil, there will be colonization, and as a result of colonization, there will be effect on the plant growth, and then this would it would sustain because it would sporulate, and then in the over the years you find that the mycorrhizal inoculum would increase in the soil. So when it is increasing in the soil, then it would increase the soil fertility as well. Even the dead mycorrhizal spores in the mycelia, they would add to the organic matter, thus enriching the soil. But when you add the other side, you see, you add inorganic fertilizer and you get the results. But what is this effect on the soil? It turns the soil inert. And over a period of time, the soil becomes unusable, unfit for cultivation. Am I clear, sir?
Thank you.
Thank you, sir. Anybody have some question? From participant sides, anybody want to have a question?
Yes, please. Go ahead.
Sir, there is a question from Saulaskar.
Hello.
He is asking one question.
How are you?
Hello. How are you, Rodriguez? Hello.
Yes, hello, I can hear you.
I heard your name. You are working on the mycorrhiza, and in our districts, fertilizer mycorrhiza are used for sugarcane and other crops of grapes. And I think that the yield of grapes or yield of pomegranate is increased. I heard your project mycorrhiza, and our friend, you know that Dr. Milind Bansode, he is working on that mycorrhiza, and he is prepared fertilizer by using mycorrhiza, and he sells us various farmers. That is very useful for the farmers. And I think that your project, that lecture is very nice to audience, to the students and to the farmers. Again, I have a chance to see you in front of us. Again, I thank you. Thanks to you, sir.
Yeah. Thank you so much. I could not make it physically because of my health problems. Otherwise, I was supposed to.
No problem.
No problem, sir. Okay.
Yeah. Thank you so much.
Hello. So my question is, what is the role of hairy root cultures in mycorrhiza?
Can you speak a little louder?
What is the role of hairy root cultures?
What is the role of?
Hairy root cultures. Your one slide is there are hairy roots formation.
EM is it's called their arbuscular mycorrhizae. See, there are two groups of mycorrhizae. We have the ectomycorrhizae and endomycorrhizae. In endomycorrhizae also there are some 4 types are there, of which one group is the EM. EM is the arbuscular mycorrhizae. Earlier they were called as VEM, VEM. That is vesicular arbuscular mycorrhizae. Now since vesicles are not found in all the genera, therefore the term the letter V was dropped and they are called as EM.
If anybody have a question, they can ask. Okay, thank you, sir.
Yeah, thank you.
Now I request Dr. Smriti sir to propose the vote of thanks.
I am very much grateful to hear for proposing the vote of thanks. I would like to thank today's keynote speaker, Professor B.F. Rodriguez, Senior Professor of Botany, Goa University, Goa, on the topic Mycorrhizing Sustainable Agricultural Development. I heard this lecture, I think previously also I am listening the lectures of Professor Rodriguez sir. This is third time, and every time he prepared a very wonderful PPT presentation on the AM fungi. In his presentation, he was talking about the importance of AM fungi, because as we know that we are using the chemical fertilizers everywhere, and because of that the more problems are created. So he was explaining the importance of AM fungi in the agriculture, and he is using the AM fungi to the different agricultural crops. And also in his presentation, he shows the very beautiful pictures of AM fungi, and also shows us the benefits of AM fungi. So I am very much thankful to BF Rodriguez sir for his wonderful presentation. Then I extend my thank to the Dr. Samadhan Mani sir. He introduced today's keynote speaker, and also thank principal of our college, Dr. C.J. Khilari sir.
Now we will begin with the next session. Chairperson Dr. Maniar sir and the resource person Dr. Chandrakanta Mahendranathan madam. She will be giving a talk on the topic impact of post-harvest losses of fruits and vegetables on food security in developing countries, with a special reference to COVID pandemic. Now I request Dr. S.V. Tide sir to introduce the today's chief guest, today's resource person and the chairperson.
It gives us immense pleasure to introduce today's resource person for this session, Dr. Chandrakanta Mahendranathan. She is a senior lecturer and head department of botany, Faculty of Science, Eastern University, Sri Lanka. Currently, she is the president of Sri Lanka University Sport Association, and she is the first ever female president of SLUSA in Sri Lanka. She was completed her PhD in post-harvest technology and pathology as a Commonwealth scholar in the United Kingdom, and carried out her PhD research in the Cranfield University, UK. She has been serving a senior lecturer at the Department of Botany, Faculty of Science, Eastern University, Sri Lanka, and she had a teaching and research experience of 23 years. She is also a member of different committees in the university. She is Vice President, Federation of University Teacher Association in Sri Lanka, 2019-20. She is Vice President, Teacher Association of Eastern University, Sri Lanka in 2019-20. President of Senior Common Room Society, EUSL in 2019-20. Her research findings have been published in several national and international reputed journals, as well as she delivered talks in the international and national conferences, also in the symposium in the different countries like USA, Australia, New Zealand, Turkey, Dubai, China, Singapore, India, and so on. Also, she served as one of the vice president of the Federation of the University Teacher Association, and in addition, she was holding various administrative positions in the past in the Eastern University. She is Director of Center of Communication and Information Technology and Director for Career Guidance. She has been involved in social services also through the International Lions Club for last 14 years, where she became the Charter President of the Eastern University Campus Lions Clubs in 2016. At present, she is serving as the Regional Consultant to the Governor of the Lions District of the International Lion Club. Thank you. So, this is the introduction of today's resource person. So, I would like to introduce the chairperson for today's function, Dr. Maniar sir. He is a principal at the Sweri College of Pharmacy. Just a minute. So, let's begin with the introduction of Dr. Mithun G. Maniar. He is a professor and principal at Sweri's College of Pharmacy, Gopalpur, Pandharpur, an experienced academic leader with a strong vision, skill and liaison with researcher, academic and industry, extensive experience of 15 years working with diverse teams and meet rapid challenges. He is a doctoral PhD completed from Savitribai Phule University, Pune in June 2019. Then he Master of Pharmacy MPhar from Nagpur, September 2008, from Nagpur University, Bachelor of Pharmacy from the Swami Ramananda Tirtha Marathwada University, SRTM in 2006. He is professor from February 2022 to till date and principal from September 2020 to till date. He established a D.Pharm course in his college, re-accreditation from National Board of Accreditation, NBA, appointed as a BOS member in pharmacy in PAHSU Solapur. Again, he has received funding from RGST of rupees 2.5 lakhs for research, recognition guide for PhD students, academic teaching and guiding to young pharm and PhD students for the research thesis. Also, he has having a good research background. He is having additional responsibilities also as a member of BOS in Pharmacy 2022 in PAHDSU Solapur. Then he is having collaborations with different industries. Also, we are also having MOU with Sweri College. Our department is also having a MOU with Sweri Pharmacy College. He has published 5 patents, 1 book chapter and various research projects. He guided to the young pharm student and completed 35 projects and 6 projects are going on. He has some reputed awards like University Topper in B.Pharm 3rd year, then University Topper B.Pharm in 4th year, first prize in the university level research competition in the Avishkar in the 2018. So these are the awards is given to the Maniar sir. So this is the brief introduction of Principal Maniar sir. So thank you very much.
Thank you, sir, for introducing today's resource person and chief guest. Now this is the time of felicitation. Now I request Professor Kilare Madam to felicitate today's resource person. Kilare Madam. Thank you, madam. Now I request Honorable Principal Dr. C.J. Khilare sir to felicitate today's research person. Sorry. Today's chief guest Dr. Principal Maniyar sir. Thank you very much, sir. Now I request today's resource person, Dr. Chandrakanta Mahindranathan Madam, to deliver her speech. The topic of the speech is impact of post-harvest losses of fruits and vegetables on food security in developing countries with special reference to COVID pandemic.
Good afternoon to you all. Thank you so much, first of all, the principal sir and his colleagues, the organizing committee, for your such a wonderful, kind invitation towards me to come from Sri Lanka. It shows that still you didn't forget me, even though I have been there before 3 years, but I'm sure that I was there online in between the COVID-19 period as well. I'm so sorry, apologize me for not pronouncing your names, calling you by your names, because it's difficult to me in my language, so I don't want to spoil your names by pronouncing by me. So, thank you so much. It's giving me a great pleasure again after 3 years of gap coming here to Maharashtra and for being with you all. Of course, I'm again telling you, I missed last 3 years the Maharashtra a lot. It's from my bottom of the heart, because I get lots of my friends, including Deshmukh sir, more than a friend. I know him for last 24 years. So more than a friend, he's like my father. So who is the godfather for me to have this network with you all? So by remembering him as well. So thank you again from Sri Lanka, from me, for inviting me for this great occasion. Thank you again. Let me come to my talk. This is actually quite a common topic that I just wanted to talk. Not just common. Well, I don't like to just be like this and talk. Anyhow, I'll talk. If I have the mic, I will be comfortable. Well, this is, it's not just common, but it's quite a hot topic as well. I would say why I just tell about my topic as hot topic, because we all talk about the production or the agriculture. The wonderful speech we heard in the morning today from our chief guest is an excellent of his experience, it shows. So we all, being botanists, being the professionals, we all are here just because for the development of our countries through whatever the field that we occupy. So particularly with talking to the agriculture, particularly the sustainable agriculture, we all are there to doing different kinds of agriculture, including the mycorrhiza. Why to have the mycorrhiza? It's to promote the production in an environmentally friendly manner. But as a whole, we all talk about how to increase the yield, how to get the product in the yield, and to feed the population which is growing day by day. So in this regard, why I say this is a hot topic after the production, my concern is, of course, as my field also, my concern is something different, because after the production of this yield, either environmentally friendly manner or through the chemical manner, whatever the way, once we produce all these agricultural produce, it's really shocking that how much we lose just before consuming it, just before eating it. That is a shocking, but it's almost, it was ignored earlier, but now the more attention is there. After the harvest of whatever the products, after the particularly the agricultural produce I'm talking. After harvest, you know what is the percentage is being lost just without reaching us to eat, to consume. That is from the point of harvest at the field and through different chains, what we call as the post-harvest chain. So through the chain of process, it is reaching us, our table to eat or our kitchen to cook. But in between that, say for example, if we harvest 10 kilograms of tomato or 100 kilograms of tomato by a farmer, do we get all these 100 kilograms of tomato to eat? The shocking news is no. You know how much is lost in between the harvest by the farmer and eat by the people? So how much is lost? Can you just imagine or roughly tell me the percentage? Is there any idea of that? Among the 100 kilograms of tomato, for example? Any idea? No, yes sir, 22-40%. That means it can be in developing countries, 20 of course in the developed countries. But the 40 of course from the countries like us, the developing countries. That means if 100 kilograms is being harvested, 40 kilograms is lost. 40 kilograms is lost without reaching us for eating, for the consumption. So we are talking and doing a research and research and research. We are doing many different technologies we are using to get more yield, to get more good produce either organically or inorganically. But unfortunately, after such wasting the money, the time, the labor and everything and the intellectual properties, everything. If it's not reaching 40 kilograms of whatever we produce, 40% of the harvested produce, what a sad conscience that. It is the truth in developing countries. Not just in the fruits, not just in the vegetables, just whole, even the leafy vegetables and everything. It's generally the fruits and vegetables. So this is where I just wanted to tell you this is kind of a hot topic and it's quite a general one. It can be the zoologist, it can be the botanist, it's just for the farmers, from the farmers to the consumers or the intellectuals levels. So why it is being lost, how it is being lost is the big worried matter, and also why I have taken again another key word here as the COVID-19, because it went, this 40% went up to 90%, will you believe me? Of course, believe me. It went up to 90% during the COVID period. This is where we are now facing, we are going to face the crisis, food crisis towards the growing population. You know the growing population is not going to be slowed down or it is going to not be stopped. It is still growing, where the agriculture sector is having this kind of fluctuations of losing 40%, losing 90% at times. Whenever the crisis is there, different crises are there. So this is where I just wanted to talk to you and make you an alert of this lost what we faced without our knowledge. We all, most of our the other people like me from the post-harvest field, yes, but other than that, all of the scientists or the farmers or whoever behind the scene are maybe not that much clear what this much is lost after wasting of all our energy or the money or everything. Even the, let's see what can be the reasons, how these are being lost, our agricultural products, how we lost that. This percentage, how, particularly I am talking about the developing countries. So how it is lost, why it is lost, and how we can prevent it, importantly. But we all could do, not just only the botanists, not just only the zoologists, not only the intellectuals. each and every level, how we can contribute. Please take as our chief guest told me in the morning, told us in the morning. I also want to say, please take this message to the right people, maybe from the farmer onwards, in the post-harvest chain, not to lose our this produce, because we need you more than us. Of course, I'm not a vegetarian, but I know Maharashtra is mostly you all are vegetarians. So you are the people need more fruits and vegetables to eat daily, day by day. So please, let's all work together. That is my message at the beginning of itself. I just wanted to give you, just looking at my presentation, it is not just the laboratory work that I'm going to tell you to follow me or to do, as again the sir told me in the morning, not just to publish, not get our promotions, but to feed our population, particularly the youngsters, particularly the children, with the food and vegetables, fruits and vegetables. You know why? Why we need the fruits and vegetables is the current good, as again I have to say thank to COVID-19, because it is the one showed us to eat the right things at right time, to boost our immunity, because we don't know how much of challenges, again how many viruses that we are going to face in the, maybe tomorrow, maybe the next year. So this is where we should not lose our produce. We have to eat more fruits and vegetables, as everyone knows, because to balance our nutrition, more than everything, to boost our immunity naturally, not by Sinopharm, not by anything, to boost our, because VB Srinathan, I myself was boosted by Sinopharm, but I am not much confident on that. I just, with the second dose, I just stopped taking any boosters, because I started to eat good things, the good fruits and vegetables and green leaves and everything. So far, thank God, I'm surviving from all kinds of corona, all kinds of, that viruses. Okay, let me move, please. So what is the next slide, please. Yes, again almost what I talked now. What is post-harvest loss again? Is post-harvest. That means the time of harvest and until we eat it. So it starts at the time of harvest. Why I particularly mention at the time of harvest? Because during harvest also we lost quite a significant percent of either fruits or particularly the fruits or the vegetables during the harvest by the ignorance of the right procedure, maybe by the damages, maybe by the damages in the sense mechanical damages. So if for mechanical damages, they are simply